Hi everyone. This tutorial is about ionic compounds. It's about what an ionic compound is, how we write the names of ionic compounds, and how we figure out the chemical formula for ionic compounds. The reference from your textbook for this section is pages 118 to 139, and we've covered a few pages in your homework book in topic 2.2 related to ionic compounds. You should know the definition below for an ionic compound. If you'd like to copy it into your notebook, you can just pause this tutorial and copy the sentence below that's in black type. Ionic compounds form when a positively charged metal ion attracts a negatively charged non-metal ion. I'd like you to try and remember that metals only have a couple of valence electrons. They'll have 1, 2, 3, maybe 4 valence electrons. They always want to lose those 1, 2, or 3 electrons so that they can have a full outer shell. Nonmetals have 4, 5, 6, 7 valence electrons, and they want to gain electrons to fill up their valence shell. So if a nonmetal has 6 valence electrons, it would want to gain 2 electrons to make 8, and so on. So metals like to form positive ions, and nonmetals like to form negative ions. And those oppositely charged ions, or charged atoms, will be attracted to each other, and they will form what's called an ionic bond. When you have 2 or more elements that are bonded together through ionic bonds, you've then made an ionic compound. So the way you can tell if you have an ionic compound or not is look for a metal with a nonmetal, and then you know you have an ionic compound. Before we begin looking at how to name ionic compounds and how to write their formulas, let's just talk for a moment about what information you can get from a chemical formula. So let's say you're looking at the chemical formula NaCl. Well, what can you tell from this formula? You can see that it has the 2 elements sodium, or Na, and the nonmetal chlorine. So we have a metal with a nonmetal, tells me it's an ionic compound. The fact that there are no numbers in this formula tell me that there's 1 atom of sodium and 1 atom of chlorine in each molecule of this compound. The compound is sodium chloride, and I just want to make sure you understand that when there are no numbers shown in the formula, it's understood or implied that there's 1 atom of each of those. But we never write the ones into a formula. Let's look at something a little bit harder. What do you notice about the names of these ionic compounds? Well, first of all, I know that they're ionic compounds because there's a metal with a nonmetal. But take a look at each one, and what do you notice in terms of patterns of naming here? So you should be starting to see that there's 2 parts to the name. The first part is the metal, and the metal's name is written exactly as it is on the periodic table. So in this examples we have sodium, calcium, potassium, magnesium. But the second part of the name, this is the nonmetal part, and the name doesn't look exactly the same as the periodic table. We need to change the ending of nonmetal names to IDE when they become an ion. So chlorine becomes chloride, fluorine becomes fluoride, oxygen becomes oxide, nitrogen becomes nitride, and so on. Sulfur would be sulfide, phosphorus would be phosphide. You need to change the ending to IDE. And that's all there is to writing the names for ionic compounds. You write the metal first, exactly as it is on the periodic table, and then the non-metal, change the ending to "-ide," and you're done. So now we'll work at learning how to write the formula for ionic compounds. So let's try a fairly easy one first. Let's write the formula for the compound sodium fluoride. All right, so first you have to decide, what am I dealing with here? Well, you have an ionic compound. I know that because I have a metal, sodium, with a nonmetal, fluorine. So this is an ionic compound, sodium fluoride. All right, here are the steps you're going to follow for writing the formula for an ionic compound. Step 1, write down the symbols for the metal and the nonmetal and their charges. So you're going to need a periodic table. Find sodium, and you'll see that its charge as an ion is 1+. Find fluorine. That's what fluoride means. It's fluorine as an ion. Fluorine has a charge of 1- when it becomes the fluoride ion. Okay, so that's the first step, and it's important that you use your periodic table to find that information. The next step is what we call crisscrossing. So what that means is we're going to take the number from the charges, and those crisscross each other down, and they become the subscripts in the formula. So in this case, the 1 and the 1 come down. However, there's a rule with formula writing. If there's a 1 crisscrossing down, do not write it into the formula. It's understood that if there's no subscript, then it means there's 1 atom. So the 1s come down, we don't write them in. The final answer is just NaF. So put the F next to the A in Na, no numbers. This is correct. This is the formula for sodium fluoride. So let's do another one. How about magnesium nitride? Okay, so you're going to have to decide what kind of compound this is. How will you know that this is an ionic compound? So it has a metal with a nonmetal. That's your clue that this is an ionic compound. The next step, do you remember what the first step was in writing the formula? You're going to write the symbols and what charge each of these elements has as an ion. Look at your periodic table. Magnesium has a 2+ charge. Nitride means nitrogen, and the nitride ion has a 3- charge. Do you remember what to do next? Well, we want to crisscross the charges down, and they become our subscripts. So rewrite those symbols with the charges, the numbers that have crisscrossed down, and this is the correct answer. So the formula for magnesium nitride is Mg3N2, and what this tells me is that in every molecule of magnesium nitride there are 3 atoms of magnesium and 2 atoms of nitrogen joined together in one big molecule. The ratio of magnesium to nitrogen is 3 magnesium to 2 nitrogen. This is how ionic compound formulas can help us to understand what we're dealing with. Now I'm going to show you an ionic compound that has an extra little rule in it that you'll need to keep in mind. We're going to write the formula for calcium oxide. It's an ionic compound because I have a metal, calcium, with a nonmetal, oxygen. Write the symbols with their charges. Find that on the periodic table. And we're going to try crisscrossing these. Well, if you're following the rules that I've just shown you, you're going to crisscross those 2 2's down. However, there is a rule for ionic compounds. When the subscripts are the same, you must factor them down to their lowest possible combining ratio. I know that sounds really complex, and it really is a little bit too complicated for me to go into why we do this, but it has to do with how ionic compounds exist. We have to show them in their lowest possible ratio of combining together. And 2 to 2 is not in its lowest ratio. If you think about it, you can reduce 2 to 2. If this were ratios in math class, you would reduce that to 1 to 1. And so we're going to get rid of those 2's, and we're going to rewrite the formula without the 2's. It's just CaO, a 1 to 1 ratio of calcium to oxygen, and that's the correct way of showing it. If you show it to me this way on a test, I will have to mark you wrong, because that's not how calcium and oxygen exist together in an ionic compound. They are in a 1 to 1 ratio of atoms, not 2 to 2. So this is an extra little rule that we have to throw in there and show you, and you make sure that you're using that whenever you're writing formulas for ionic compounds only. This rule only applies to the ionics. Okay, thanks for watching.